This video is to show you about conjugate acid-base pairs. A conjugate acid-base pair pairs the acid with what's left over after it loses the H plus 1. So, since it's a proton donor, it would lose an H and it would lose one from its charge because that H has a proton. So, to go from the acid to the base, you have to subtract off not only a hydrogen, but also a plus 1 charge. So, for example, HBr would become Br. It was neutral. You take away 1, so it's a negative 1 charge. To go the other way, so from the base back to the acid, you add H plus 1 on. Again, that H has a proton, and that's why we have to add the plus 1. So, for example, SO4 negative 2 becomes H SO4, and then it was a negative 2 charge, and you add 1, so now it's a minus 1 charge. Now if we treat water as a base, so we're going from base to acid, so we have to add a hydrogen, and if you forget which one subtracts and which one adds, remember when you're looking at your pair, the one that has the most hydrogens has to be the acid, so you can always check yourself in that way. Okay, so we have H2O and we're adding an H plus 1, so that becomes H3O. It was neutral, so now it's a plus 1 charge. Water is one of those unique substances that can also function as a base, or an acid or a base. So here I used it as a base, but on the next one we'll use it as an acid. So this one we take an H away from the water, which is H and O. It was neutral. We add 1. Wait, no. We take 1 away, sorry. We subtract 1. It becomes hydroxide. And hydroxide is normally written OH rather than HO. So it really would be OH negative 1. So hopefully that helps with acid-base pairs.